Okay, so this is the test review for Chapter 6. We'll start here with question number 1 and 2, which are all about breaking down different types of roots. So this is the fourth root of 32, and number 2 is going to be the cube root of negative 27. If I try to put these in the calculator, sometimes they come out as whole numbers, other times they come out as decimals. A decimal is not an equivalent value because it's an approximation. It's not the same number. We have to round it at some point. We don't want to round it, so we want just the simplest version of the root. Well, because this is a fourth root over here, that means that when I break the 32 down, I'm looking for 4 matching numbers. If I start, I'd have 2 and 16. Well, 16 is really 2 and 8. Now, keep in mind, the 32 and the 16 have already been split, so they're no longer in existence. I'm going to keep breaking the numbers down. I get 2 and 4. Now, at this point, the 8's gone. How many 2's do I have? It looks like I've got 3 of them so far. So I need to go at least one more. And now I have 5 2's, but it only needs 4 to get out. And so I'm going to circle a group of 4 of the same thing. That gets to come out and become a regular 2. And then I have this guy who was not part of the group, but was part of the breakdown. He doesn't have enough to be part of our group, so he gets left behind. Sits inside of that root. Another way to think about this, okay, if we want to think about it, this is really 2 to the 5th, because there's 5 2's. So I could think of it as the fourth root of 2 to the 4th times the fourth root of 2 to the 1st. That's my total of 5 2's. And so if I think about it, the fourth root and the fourth power would cancel, leaving me with a 2. And then there's the fourth root of 2 that I couldn't simplify. Either way, I should get to this point. Again, it takes 4 things to get out of a fourth root. If this was a 5th root, I would take 5 things. So on that same note, when I come over here, you see this negative, and you might first think that this is going to be imaginary. Well, because this is an odd root, meaning not divisible by 2, there's a chance that we can get this to work out. So if I think about splitting 27, my first thoughts are of 3 and 9. But I'm supposed to somewhere account for the negative, so I'm going to stick it with the 3. I do that on purpose. You just take one of the small values and just throw it with the negative with the small value. Then the 9 splits as 3 and 3. The issue here is I don't have 3 matching numbers because one of them is negative and the other 2 are positive. But because negatives in pairs, when you multiply, give you a positive, I can use a negative 3 and a negative 3 for my positive 9. And if I look at this, I have 3 negative 3's that make the negative 27. So in this problem, the answer is just negative 3. We could have put that one in the calculator, the cube root of negative 27, or negative 27 to the 1/3 power, and it would have given us the negative 3. But we wouldn't really know that was going to work unless we either tried it or tried this method. I'd suggest that you try this method as much as possible. Looking at the next question, number 3, okay, it says we have x to the 4/3 exponent, y to the 2/5. Is that right? 2 over 5 over x to the 1/3 y to the 12 over 5. So a couple things to keep in mind here. We don't typically like to have x on top and bottom, and same thing with y. We like to just have it once if possible, but we're not supposed to get negative exponents, and we're not supposed to leave fractional exponents in the bottom. So if I think about splitting this and just thinking about my x's first, the bigger x pile is on top. Whenever that's true, we subtract up because we'll never end up with a fractional exponent in the bottom. So we can always go up if the bigger pile is on top. Okay, so here we get x to the 0 on bottom, which means it's gone. On top, though, what is 4/3 minus 1/3? That turns out to be 3/3. Now, if it had been 7/3, that's fine because it's on top. Now, 3 over 3 does just so happen to just be x to the first. But let's look at our y's and see what happens here. Now the y is bigger on bottom. If I were to try and subtract the 12 over 5 up, I'm going to get a negative number, which is not okay. But if I subtract 2/5 down, the question is, will I get a whole number? If I don't, then moving it down is not a good option either. In this case, if I minus 2/5, 12/5 minus 2/5 is y to the 10 over 5. But 10 over 5 does divide to give me just y squared. And there's my answer. Okay? So if it hadn't cleaned up so nicely, I'd have to, let's say for instance, this had been y to the 9/5. I'd have to add a y to the 1/5 on top and bottom to get it to balance. And we can ask those kinds of questions in class if you have them. If we keep looking at this type of work, number 4, it looks a little bit more like the first two, but it has the 4th root of 2 plus 8 times the 4th root of 162. So the general rule here, guys, is that I can't actually add these two roots unless this and this match. And because they don't match right now, I can't move forward until I try to break the roots down. So that's my first goal, is to come over here to the 162 and see if I can break it down and end up with a leftover 2. Well, let's try 2, and it turns out to be 81. Well, 81 is 9 and 9, but the 9s are 3 and 3, 3 and 3. And remember, the 162's gone, the 81's gone, the 9's gone, the 9's gone. So if I start looking at this pile of stuff I have down here, how many 3's do we have? There's 4 of them. And because this is a 4th root, just like question number 1, the 3 can come out and hang out with the 8. But there is this leftover 2. So if I come down a little bit, give myself maybe a little bit more room here, I've got the 4th root of 2 plus. One of the big questions is, how does this 3 connect with the 8? Well, if I think about what math symbols exist right in here, it would be a multiplication symbol, so I'm going to multiply these together. 8 times 3 is 24, and I'm left with a 4th root of, the only leftover piece was 2. Now my two roots match, and if you can imagine, this is like 1 root 2 plus 24 root 2. That should just add up to give me 25 4th root of 2. The biggest issue is making sure that we break the bigger root down first to make sure we can get them to look identical. Because if they didn't both make root 2, we wouldn't be able to do the process of adding them. If one turns out to be root 3 and the other is root 2, we're stuck and we can't move forward. All right, so now we're going to do some composition, some function rule stuff. Okay. I give you a couple different functions. If you're looking at the work there, f of x for this is going to be negative 3x squared plus 14x minus 12, and g of x is equal to 6x minus 3. And the first thing I'm asking you to do is g of x plus f of x. So I'm going to take g of x, which is 6x minus 3, and I'm going to add the other function, which is negative 3x squared plus 14x minus 12. Now, if it was a negative subtraction, I'd have to distribute that negative. But because this is addition, okay, I just get to add like terms. We always try to look for the biggest like terms first. Negative 3x squared doesn't have any, but it is the biggest term, so negative 3x squared would be my first term in my answer. And then I'm looking for other like terms. There's 6x and 14x. I'm just adding, so that's plus 20x. And then I have a negative 3 and a negative 12. That's negative 15. And that would be my answer. Woo! I'm off a little bit right now. But so the idea is we just add like terms. Nothing fancy there, okay? Let's see if I can move that around a little bit. So you guys can, oh, the negative 15 wants to hang out with that. All right, so you guys can see what it is. Go back and rewind it if you need to. And then the second part, number 6, keep using those same equations. It says f of g of negative 1. Okay, and so the idea behind f of g of negative 1 is that we're going to take the negative 1 and plug it into function g, and then we're going to take the answer from g and plug it into f. This is a double substitution or a layered composition. So the first thing I need to do is figure out what is g of negative 1. Well, if I look at equation g, it was 6x minus 3. That means I'd have 6 times something minus 3, but that something is negative 1. Well, 6 times negative 1 is negative 6, minus 3 is negative 9. So now that answer needs to go into f. So f of negative 9 would equal negative 3 times something squared, I'm just reading off the equation, plus 14 times something minus 12. And that something in both these cases is a negative 9. Now we can calculate this individually, or honestly, this whole thing from beginning to end, if you put it all in the calculator at the exact same time, your calculator will manage just fine to give you negative 381. Or you can calculate it in hand, but be careful to make sure that you do order of operations correctly, starting with those exponents. Oops, I want to add a page there first. Okay. Now 7, I give you two functions. I tell you that f of x is equal to 3x minus 4. Sorry about the board. And g of x is equal to, let's see if my finger will work better. X plus 4 all over 3. And so our goal is to show, or sorry, f inverse of x. But either way, we're trying to show that these two functions are opposites or inverses. The way we do that is by putting one function inside the other. So that would look like 3 times something minus 4. But the something is going to be x plus 4 all over 3. The important process here is that we show the work a step at a time. I'm going to use different colors. First thing I recognize is that multiplying by 3 and dividing by 3 at the same time would cancel, leaving me with x plus 4, and then there's a minus 4 out here. And then if I took a plus 4 and a minus 4, they would cancel, leaving me with just x. That's the goal. To prove it, I want to show it both ways. That doesn't work both ways. Over here, it would be something plus 4 all divided by 3. Well, the something is the other equation, 3x minus 4. Well, here we would see that the minus 4 and plus 4 would cancel, leaving me with 3x over 3, which we know that the 3's would cancel, leaving us with just x. Okay? And so doing that, we're able to finish that part. Okay, from there we go to question number 8, where you're asked simply to find the inverse of g of x equals 3x cubed minus 8. So the rule for finding an inverse is that we switch x and y. So this simply becomes x equals 3y cubed minus 8. And now we need to solve for y. Well, the first thing I would do is I'd add 8 over, making it x plus 8 equals 3y cubed. Now I want to get rid of that times 3, so I'm going to divide by 3. And then to get rid of a cube, I would cube root. So I could even apply that cube root to the whole thing here and say that my new function, the inverse of g, you could also just write y equals. I wouldn't mark that wrong, but the inverse of g is the cube root of x plus 8 all divided by 3. Okay, that turns the page. We've got 2 to solve. We need to solve number 9.